Okay, so today we're going to look at multiplying polynomials. First of all, a monomial by a monomial. And really, we've already done this. When we reviewed powers and roots, we looked at multiplying, for example, if you look at B here, multiplying these factors together, and that meant multiplying the coefficients, multiplying the powers. In this case, they have the same base, so we add the exponents. So you do need to know those power laws for multiplying. So for a monomial by a monomial, method is multiply the coefficients together, then multiply the variables together using the power law. For example, multiplying powers with the same base, you add the exponents. So we're going to do these. Bear with me, I don't have a tablet, so I'm using my mouse. So my writing might be a little bit messy. Okay, so first one, 12 times 2 is 24. X times x is x squared. Okay, so pretty straightforward in that case. Remember, if there's no exponent shown, it means it's a 1. So 1 plus 1 is 2. B here, I'm actually just going to change to blue. B, coefficients. Coefficients are 3 and 5, so 3 times 5 is 15. And x to the 4th times x squared, you add those exponents, so those are plus, and so that'll be x to the 6. Next one is a negative 6 times a negative 4. So those are coefficients, so you multiply. Just if you had negative 6 in brackets, and negative 4 in brackets, you know that you would multiply. You wouldn't add them. Adding is only for the exponents on powers with the same base. So that's going to be positive 24. Then x, that's x to the 1, times x to the 5th is x to the 6th. And then y squared times y to the 7 is y to the 9. Next one, 3 factors. So a negative 3, a 2, and nothing in front there, which means a 1. So that's going to be negative 3 times 2 times 1, which is negative 6. Then m to the 6 times m cubed times m to the 1. So that's going to be m to the 10. There we go. And then n's, so n is n to the 1, n to the 1 there, and n to the 11. So 1 plus 1 plus 11 is n to the 13. Okay. Now we're going to look at multiplying a polynomial by just a constant. Remember, a constant is just a number. So it says, state the expression represented by the following algebra tiles. So if you remember back to yesterday, or I guess it was last week, the long skinny ones that are colored are x's, and the little squares are 1s. They're constants. So there we have 3x plus 6. Okay. Then the second part says show the multiplication expression for the area of the rectangles formed by these tiles. So basically, on the outside, we want to state, okay, what does this length represent? Think about it being a rectangle. Well, that is x, and this is plus 2. Here, if we look this way, that dimension is the same as a dimension of 1. Remember, these are 1 by 1s, these little squares, so that's going to be 3. Okay, so the multiplication expression is 3 times x plus 2. Okay, and so let's take a look at how that relates to this. If we take 3 and multiply it by x, we get 3x. If we take 3 and multiply it by 2, we get 6. Okay, so 3x plus 6 is the same as 3 times x plus 2. So that's the distributive property. Any constant, we'll get into monomials as well, out front of a bracket, you multiply every term in the bracket. Okay, so next one, same deal here. So we have x, oh sorry, let's count up. We have to look at how many tiles we have. So we have 4 x's, and we have 4 little boxes, but they're white. So that's -4 because they're negative. In terms of what we're multiplying, that dimension is x. This dimension is 1, but it's white, so it's -1. And this dimension is 4. Okay, so now our multiplication expression is 4 times x minus 1. Well, how does that relate to this? We want to multiply x by 4 and multiply the constant by 4. So 4x minus 4. Okay, so here's the method in words. Multiply every term in the polynomial, that is inside the brackets, by the constant term. That means you are multiplying each coefficient by the constant. Note, it is always a good idea to check for like terms in case the polynomial inside the brackets was not in simplest form. If this bracket is in simplest form, which these have been, then you're not going to have to collect any like terms at the end if you're multiplying by constant. But if it wasn't, then you would always check at the end if you can simplify. Okay, so let's practice here. So 4 times, so I just used arrows here just to remind myself. Okay, this is a binomial. There's 2 terms, so my answer should be a binomial if it was simplified to begin with inside the brackets. So that's going to be 8x plus 32. B, then you use the sign in front of your constant. The constant is -3, so it's -3 times 5 is -15x. -3 times -2 is +6. Okay, now a constant times a trinomial. So the trinomial's already in simplest form, so that means our answer will be a trinomial as well. So 5 times 3 is 15, x squared, then minus 20x plus 35. Okay, now take a look here. We have a trinomial and then multiplied by a constant here. Doesn't matter if it's at the beginning or at the end. Normally we show it at the beginning, but it doesn't matter. We still need to multiply every term by the constant. Now you could start by, actually I'm just going to erase that. You could show it like in the first bracket. You could go, okay, first term times that constant, then the next term times that constant, and then the next term. Or the arrows can go the other way. It doesn't really matter. You get the same result. Get -3 times -2x squared is +6x squared. X times -3 is +3x. And 8 times -3 is -24. All right, so that was by a constant. Now we're just going to have it be a monomial. So there might be a variable in that factor out front. So state the multiplication represented by the guiding tiles. So these are the guiding tiles. So what do we have here? We have 2x tiles, and we're multiplying, which we don't show the multiplication symbol because it looks a lot like x. We use brackets, and this is an x tile and 2 1s. Okay, then fill in the rectangle formed by this multiplication and state the expression. So I'm back. I had to fill this in. My computer the program kept crashing when I was trying to do these squares. So in any case, I filled in with the correct tiles that form the answer to this multiplication. So I've got to go back here to fill in. So sorry, I didn't. I had to clear it off. So this was 2x on the left, and then x plus 2 on the top. Okay, we filled in. So what do we have here? We have 2x squareds. Remember, the big squares are x squareds area, and 4 x's. Okay, so let's take a look. How is this found from this multiplication? Well, 2x times x, remember that's an exponent of 1 on each, so that will be 2x squared. And then 2x times 2, well, 2 times 2 is 4x. Okay, so same process, every monomial, the monomial out front gets multiplied by every term inside the brackets. Okay, so another type of area which doesn't involve algebra tiles, a little bit easier, is just to show the actual dimensions. So, and not split up into algebra tiles. And this way you can actually show more different terms than just what we have with algebra tiles. So state the multiplication represented by the area of the rectangle. So I always look for the monomial first and show it. So that's x, then multiplied by 2x plus 3. Okay, that means it's split into parts. That's the dimension of each part. So we add them together. So that's 2x plus 3. Okay, and then the area. So think about length times width. That'll be 2x times x. If you're thinking about just length times width, the unit that we just finished, that's 2x squared. And length times here is 3x. So the answer is 2x squared plus 3x. It looks like I forgot to close the brackets up top, but let's see how that compares. So if I take the monomial times 2x, remember that's an exponent of 1 on each, so that'll be 2x squared, and then x times 3 is 3x. So in words, the method is multiply every term in the polynomial that's inside the brackets by the monomial. That means you will be multiplying the coefficients and then multiplying the powers with the same base. This is called the distributive property. So let's practice. Okay, so 4x, so remember that's an exponent of 1, exponent of 1. So 4x times 3x is 12x squared plus 4 times 8 is 32x. Next one here, it's just negative, that's all. So negative 3 times 5 is negative 15. Remember that's x to the 1, so x to the 1 times x squared is x cubed. Then negative 3x times negative 4, so that'll be a positive, so a plus 12x. Next one, now we have a trinomial. Notice how the trinomial, there's no like terms, it's simplified, so we should end up with a trinomial. Okay, so 5 times 3 is 15. That's x to the 1, so x times x squared is x cubed. 5x times negative 9x is negative 45x squared, so I'm going to put subtract 45, and it's x squared because that's x to the 1 times x to the 1. And then 5x times 7 is 35x. Positive, so it's a plus. Now the monomial is at the end. Doesn't matter. We're going to take each term and multiply it by the monomial. There's some x's and some y's. I'm just going to put it underneath because I write a little bit big here. So 2x squared times negative 3x, remember that's to the 1, y to the 1. So that's going to be negative 6x cubed y. Then negative xy times negative 3xy is plus 3. X times x is x squared, right? Because that's a 1 and that's a 1. And y times y is y squared. And then positive 8y times negative 3xy is negative, so it's subtracting 24x and then y squared. Okay. Then our monomials are getting a little bit more complicated. It's still a monomial, there's no adding in there, so it's the whole thing multiplied by the first term, second term, third term. Remember, if there's just one variable, it means an exponent of 1. Okay, so 3 times 5 is 15. X cubed times x cubed is x to the 6. And then y squared. Then positive 3 times, remember that's a negative 1 in front, so that's going to be negative 3, which is subtract 3, x to the 5th, and y cubed. And then 3x cubed times y squared times 8y is going to be plus 24 x cubed y cubed. Okay, and you'll also notice that if the polynomial in the brackets was in descending order of degree, then your answer will be as well. Okay, so these were both degree 3 terms and then a degree 1. And so these are both degree 8 terms and then a degree 6 in this case. Okay, and then same thing, multiply everything by that monomial, including the sign in front. So negative 4 times 3 is negative 12. Remember, x is x to the 1, y is y to the 1. So you can put those in there to help you remember. So negative 12, that's going to be x to the 5th, and then y to the 5th. And negative 4 times negative 1 is positive 4. And that's going to be x squared y to the 6. And then minus 8x y to the 6. Okay, and that's multiplying polynomials by a monomial.